Hey there, hi there, ho there. Welcome to Unit 7, Sediments and Sedimentary Rocks. So this is the next kind of step in the rock cycle after talking about igneous rocks and the processes that create those. Although it doesn't necessarily always have to be igneous rocks, then sedimentary rocks. It's just a nice way of teaching it. We did touch a little bit on sedimentary rocks back in Unit 5, just briefly talking about them. Sedimentary rocks are formed from sediment. So you had a pile of sand, which is considered sediment. When you take sediment, when you compact it and cement it together, then you get sedimentary rocks. They're typically earthy in color. Sometimes you see layers. Sometimes you see pieces of all kinds of different rocks. To me, it's a personal thing. They're not the most fun rocks, but they do tell one heck of a good story. So, in order to get sedimentary rocks, we first need sediment. To get sediment, we need to break down rocks. So, in the rock cycle, we kind of finished talking about igneous rocks. We're first going to talk about a process called weathering, which is the breaking down of existing rock. You take that existing material, break it down into small pieces, sediment. You take that sediment, you erode it, you move it somewhere and deposit it, and then compaction and cementation gets you sedimentary rock. So we're going to be in this realm of the rock cycle. As you can see, this is affected by solar energy, which affects the water cycle, which intersects the rock cycle right here when we're talking about sedimentary rocks. So, weathering versus erosion, these are two different processes, and I want to make sure you understand these. Weathering, as defined, is the chemical and physical breakdown of rock. So this is taking a rock and breaking it down. Erosion is the transport or movement of particles of rock. It could be gravity pulling material down, air blowing sediment in water in a river flowing downstream, ice, glaciers as they move, they kind of pick up stuff and move it with it. So erosion is the movement. Weathering is the breaking down, erosion is the movement. I think a lot of times on TV or movies, they just use the term erosion to mean both breaking down of material and movement. Not the case. They do work together, but they're not the same thing. If you can imagine, weathering is like a hammer breaking things down. Erosion is like a truck moving stuff. So they can work together. They're just different processes. So again, weathering is the breaking down. Here's a nice little image. Weathering is the breaking down of the rock, however that may occur, which we'll talk about. And erosion, again, is the movement of that material. Okay. So there's two types of weathering. There's two types of processes, larger kind of processes that break down rocks, that weather rocks. First is called mechanical weathering. Mechanical weathering is the process of breaking down rocks into pieces by some sort of physical process. There's some sort of physical aspect going on. If I were to take a hammer and start to break this rock down, I'm physically interacting with this rock. So that's mechanical weathering, some sort of physical interaction. In this case, and this comes into play here in a little bit later in this video, but the chemical composition of a rock is not changed. There are a few different types of mechanical weathering. We'll explain each of these. Sheet jointing, sometimes known as exfoliation. Frost wedging, root wedging, salt wedging. Oh my gosh, this lady is pulling off her face. No, she is exfoliating. Just like in the skincare realm, exfoliating your skin means taking off layers of your skin, whether you use a sort of scrub or mask. I don't know how that works. But so exfoliating your skin, you're kind of peeling, you're taking off layers of your skin to get healthier skin, to expose new, fresh skin, essentially. Well, kind of the same thing happens, but with rocks. So sheet jointing, also known as exfoliation, in this case, heat, the sun, the heat as it hits rocks, the rocks, when heats up, they expand. When things heat up, they expand generally. So as these rocks heat up, they expand. At night time, they cool, and when things cool down, they shrink. So this repeated pattern of expanding, shrinking, expanding, and shrinking begins to break and flake off layers of rock. And that's, you can see kind of the layers kind of coming off of this rock. That would be sheet jointing exfoliation. A lot of times it's with kind of more rounded structures, but not always. Not always. So this is, I believe, Half Dome. This is Half Dome in Yosemite National Park. Yes, that's the line to climb to the top. That's why I have never gone to Yosemite National Park. Too many people. In any case, this is a good example of sheet jointing exfoliation, a physical process where rocks are being kind of broken off because the rock itself is expanding and contracting, expanding and contracting. When it does, pieces break off. Has this ever happened to you? You got yourself a nice, delicious soda pop. You want to drink it, but it's a little warm. You throw it in the freezer. You forget about it. You go back a couple days later. This has occurred. Do you know why this occurs? Well, soda pop and most beverages contain mostly water. Water is this weird thing. When things heat up, they expand. When they cool, they shrink. Water's kind of weird. When you heat up water and you boil it, it expands. But when you cool it, it shrinks to a point and then it begins to expand again. It's this crazy stuff. So when you're going from a liquid water to ice, so ice kind of expands. So if you have a can of pop, again, which is mostly water, you throw it in the freezer, that water essentially, when it freezes, it expands and kind of busts the can. Well, same thing in nature. Let's say there's a crack in a rock and it rained during the day. Well, at nighttime, maybe in this area, it gets cold enough to where the water freezes. Well, the water's going to expand and it just kind of applies some pressure on that rock. And then, the next day it melts again. Maybe there's still moisture in there, so it freezes again at night, melts, freezes. So as this process occurs, and water and ice is actually very strong as well. You can actually begin to open up a crack, create a bigger crack, and even sometimes just split a rock right in half. All from just freezing water. And that's a process called frost wedging. So water trapped, even if it starts off as in small little cracks, water trapped in cracks freezes and expands. It can crack a rock open just like an egg. I mean, you can see like a bush here. I can imagine this is probably about 3 or 4 feet tall in itself. So this rock is probably 8 feet tall, just cracked right open. Another type of physical process where there's a physical interaction breaking things down is root wedging. Kind of obvious. You get a little plant or tree kind of started off growing in a little crack. Over time, as that tree or plant gets bigger and bigger and bigger, the roots get bigger and bigger and bigger and just physically wedge and break the rock apart. That happens. And then salt wedging. It's similar to frost wedging in that it uses water, but in this case, when you have some types of rocks near salty water, like ocean water, like we can see back here, that salty water, if the waves kind of crash onto a rock, kind of also make its way into the pores and cracks of the rock. But if the water evaporates, it leaves behind that salt material, and that salt material can accumulate, crystallize, grow, and also as that crystal grows, will kind of begin to, even little pieces, little flecks of rock begin to wedge out material as that salt crystal grows in the crack or little pore or little space in that rock. So that's mechanical weathering, physical interaction. Water is physically breaking it down, salt physically breaking down, roots physically breaking down. That's mechanical weathering. And then you have something called chemical weathering. It's the breakdown of rocks and minerals by a chemical and or biochemical reactions. So these are chemical reactions. The chemical composition of a rock is changed when chemical weathering has occurred. Types of chemical weathering include oxidation, hydrolysis, and solution. So oxidation is just a fancy, sciencey name for rust. So oxidation as a form of chemical weathering is the breakdown of rock by oxygen, oxidation, and water, like hydration, oxygen and hydration, oxidation. So some rocks contain iron. Iron, when you expose it to oxygen and water, rusts. So what you can see here in this rock is this side of the rock looks rusted, like a rusty old car. Well, this doesn't. My guess is there was something covering this portion of the rock, or this rock was kind of in the ground. It was not exposed to the oxygen in the air or directly to the water in the atmosphere. So something was kind of covering this up. But this side was just exposed to the elements, oxygen and water, acted on this rock, which probably contains some sort of iron to help rust or oxidize it. You know there's an oxidation chemical weathering occurring typically with a change in color. There are certain minerals, some of which we looked at in the Unit 4, Unit 5 lab, some not. But minerals like pyroxenes, amphiboles, magnetite, pyrite, and olivine are all susceptible to oxidation because, again, they have a high iron content. Some of those you identified in lab, some not. But again, a lot of rocks contain these minerals. So a lot of rocks are susceptible to oxidation. When they rust, material flakes off. It's chemical weathering. Hydrolysis. This is actually up in Prescott. It's the breakdown of rock and minerals due to chemical reaction caused by water. So water just falling on some things can cause a chemical reaction. Water changes the chemical composition and size of minerals, some minerals in some rocks, making them less resistant to weathering, meaning they're more susceptible to being broken down. Granite is commonly susceptible to hydrolysis. So as water interacts with these rocks, as it rains, as it snows, as it does whatever, the chemical the makeup of the granite itself kind of becomes less resistant to weathering, and it can be broken down. And you often see these rounded, cracked rocks. So this is up in the Prescott area. If you drive up the 17 up to, you'll see stuff like this. If you drive up Route 87 up to like Show Low, you'll see rocks like this. A number of different places in Arizona you can see rocks like this. And the last type of chemical weathering is solution weathering. Removal of rock in solution by acidic rainwater. Kind of like what you imagine. You drop acid on something, it begins to fizz or break down. Yeah, kind of similar to that. Carbon dioxide, CO2, which we put into the atmosphere as we burn fossil fuel, we drive our cars, etc. As we put that CO2 into the atmosphere, it's causing climate change, and a fun little extra, actually not so fun little extra byproduct is that the CO2 also dissolves in the air and gets into the rainwater, the moisture into the air, and turns that water weakly acidic, carbonic acid. And hence, when that material comes back down, it's known as acid rain. Now, it's not like what you would think about in the movies where someone's out and it starts to acid rain and their skin starts to boil and burn. No, it's very, very, very weak acid. However, there are some rocks like limestone, which is actually a sedimentary rock, that's very susceptible to solution weathering, very susceptible to carbonic acid or any weak acid. So a lot of statues and gravestones on the surface, or even caves below the surface, are made out of limestone. So when you get this acidic water hitting this material, this limestone material, and a number of other types of rocks and minerals, it just breaks down. So again, a lot of statues are made of limestone. Marble is also susceptible to weak acid. A lot of limestone makes up the bedrock of areas. Florida is a lot of limestone. As that rainwater then hits the ground and filters into the ground, it dissolves out that limestone in the ground as well. So what we're going to do is we're going to take a pause right there. We just kind of talked about how things are broken down, mechanical or chemical weathering. When we come back, we'll talk about factors affecting weathering. What's going to cause an area to weather faster, slower, etc. See you back here in just a minute.